My research is on the properties of ice melange. So an ice melange the word basically means a mixture. So what it is it consists of ice, sea ice, and glacier ice, specifically in front of a tidewater glacier. It's a type of glacier that juts out over the ocean. An ice melange is kind of like a dam out in front of the glacier. It's kind of holding back to a certain extent. And you could imagine if you just remove a dam, from any setting, the water behind it will kind of spew out. The same thing would happen if you just remove an ice melange out from in front of a glacier. All that ice behind will start accelerating and moving faster. And that just means more and more ice being emptied into the ocean and leading to sea level rise. My hypothesis basically says that if this ice melange is in front of the glacier, it's going to reduce the amount of calving. So calving is when the ice breaks off, and particularly it's going to reduce the amount of capsizing. This is a GPS receiver, so that stands for Global Positioning System. It's actually very accurate, much more accurate than the GPS that you would have in your phone. So we use it to see how fast maybe a particular glacier is moving. Ropes. Depending on where you go, you might need to be on belay in case you fall into a crevasse or anything like that. And these are some of the boots you might wear. The way I would like to study this, because ice melange is found in a very remote setting, and it's actually a pretty dangerous one. When these icebergs break off and capsize into the ocean, they let off a lot of energy. Sometimes they create waves that can be up to 20 meters in height. So it's a pretty dangerous environment. So what I propose to do is study it in a laboratory setting. Some of the things that I would want to study would be pretty much impossible to do in the field. Basically, my setup would be a large tank, basically an aquarium tank, and I would try to configure it to model the edge of a glacier. On one end of the tank, I would have these plastic blocks. These would basically be the icebergs that would break off and tip over. I chose a particular type of plastic that is around the same density of ice, so that way I wouldn't have to worry about melting ice cubes, so it makes it just a little bit easier. And then I would construct a melange out in front. So this melange would be made of smaller pieces of plastic, and then also a layer of paraffin wax. The smaller blocks would model blocks of iceberg that have broken off, and then the wax would model the sea ice. The good thing with that is I could melt the wax because sea ice melts a little bit quicker. So specifically, I'm studying a glacier in Greenland. It's called Helheim Glacier, and it's a tidewater glacier. And the reason why I chose it is because my lab group already has some remote sensing data from that glacier. In general, I think ice tends to be one of the more sensitive aspects of our planet that is sensitive to changes in climate. And I think as an academic scientist and researcher, kind of my responsibility to kind of look at some of the biggest challenges that are happening today, the biggest challenges facing our planet, and I think facing humanity even. I think climate change is probably the biggest challenge we've ever faced. And I think that my experiments and my research will at least help contribute to monitoring how the polar regions of our planet are going to change in the coming years and what's going to happen to the future. 99% of scientists think that climate change is happening, and they think that it's due to human causes.